Hi, and welcome to today's webinar, New Tools to Profile Backlit Materials. Presenting today is Jay Calbley, the Product Manager at X-Rite Pantone for the I1 family. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few quick things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions, please use the questions function on the GoToWebinar panel, and we will have some time at the end of this webinar to answer a few of your questions. Finally, this webinar will be recorded and you'll receive a link so that you can review this webinar at your convenience. So with that, I'll turn it over to Jay to get things started.
Thanks, Robert. So my name is Jay Calbley. I'm the Product Manager at X-Rite for the I1 tools. And most people in the printing world are familiar with I1s. They've got one or several of them. If you're doing any kind of digital printing, it's really the standard tool used by most people for calibrating or linearizing, as well in many cases for profiling. So for the I1s, just a little brief history, the original I1 Pro is on the right there, and then the I1 Pro 2, which is now being replaced by the I1 Pro 3, which is the latest and greatest version. With the I1 Pro 3 family, we did something different. We made a direct replacement for the I1 Pro 2, which has a 4.5mm aperture, what we call our standard aperture. But we've also come out with an I1 Pro 3 Plus. The Plus is a large aperture device. It measures an 8mm spot size. And it's really targeted for all these new materials and substrates that people are using in digital printing. One of the other advantages or different changes is we enable polarization or M3 measurement with the I1 Pro 3 Plus, or the large aperture version. Both models can be automated with an I/O. So our third generation of I/O unit, I1 I/O, is the I1 I/O 3. It's modified or designed specifically for the I1 Pro 3 and Pro 3 Plus units. It's not compatible with I1 Pro 2s though. So if you have a current I/O device and you get an I1 Pro 3, you're going to need an I/O 3 to work with the I1 Pro 3 and Pro 3 Plus. Just wanted to compare some of the key features. Again, measurement aperture is the big difference between the standard aperture and the Plus version. With that, the aperture size dictates the minimum patch size that you can use. There is some improvement in patch size from I1 Pro 2 to I1 Pro 3, so you can go down to 6mm patches, which means you can get more patches per chart and potentially fewer charts and less material used. These devices are also used for display calibration and display measurement. One big difference between the Pro 2 and the Pro 3 is the top luminance that you can measure. We moved it up from 1200 nits or candela per square meter to 5,000 nits. So that's important for people who are doing LFDs or large format displays, like you'd see at a McDonald's drive-through, because those can be up to 5,000, 7,000 nits in some cases. We doubled the sampling rate. So the I1 Pro 2 would measure 200 hertz or 200 samples per second. The I1 Pro 3 architecture allows it to read 400 hertz in scan mode. That means you're getting twice as many samples over time, which means you're going to get a better averaged measurement. Scan length's the same, except for the I1 Pro 3 Plus. With its larger patches, since you're probably using larger samples, we essentially doubled the maximum scan length. We changed from a tungsten light source to an LED light source. That makes the devices much more reliable. It also enables single pass scanning, which I'll talk about in a little bit. The LEDs that are in the I1 Pro 3 aren't just a single LED, it's an LED cocktail. A bunch of different LEDs used to give a full optimized spectrum of light. Ring illumination, single pass scanning. I talked about that a little bit. With the I1 Pro 2, if you ever did scanning where you needed UV measurement, you'd have to do one pass for visible and one pass for UV, so 2 passes. With the i1 Pro 3s, it gets everything M0, M1, M2 all in 1 pass. Easy clean filter is a big deal. If you use an i1 Pro 2, it's a bit of a challenge to clean that device. The i1 Pro 3, you just twist off the snout or the tubus. You can pop the filter right out, clean it, which is awesome. We also have a polarization option that ships with the Plus. Again, you just pop off the filter and put on the M3 or the polarization filter. And then we've enabled transmission profiling, which is really what I want to talk about today on the i1 Pro 3 Plus. So again, the Plus was designed for a bunch of different materials. Because of the large aperture, things with uneven surfaces or weaves or textures like printed ceramics or corrugated, a lot of the materials used in signage, etc. But there's a ton of people printing on textiles and films for backlit applications. Not a lot of people profile historically for backlit or transmission, really because the tools weren't available, or they're very, very expensive. So many people didn't profile at all, or they would just use canned profiles for transmission. Again, automation's a big thing with the i1s. You could buy your i1 and hand scan on it or spot measure, but if you want to automate it, again, the i1 I/O is a great way to do it. You just pop your i1 device into the cradle of the I/O, and it uses what they call a SCARA arm, or robot arm, to automatically move across the patches and measure them. With the IO3, a couple new things. The IO3 ships with 2 different glider rings, one for the standard aperture, small aperture, and one for the large aperture. So depending on which device you're using, you pop in the glider ring appropriate for it. The glider ring is really important. It minimizes the friction on as the device is moved around the sample, and those wear out over time, so you can always get more from us if you need them. The IO3 and any of the IO devices can measure samples up to 10 millimeters thick, which is pretty thick, but that's about the thickness of a carpet tile if you're measuring something like that. If you need to measure something thicker, we just launched an IO Z-axis spacer. This will give you another 23 millimeters. So if you need to measure something thicker like cardboard, or you want to put a big thick Lightbox on your IO, you can use one of these spacers to get up to 33 millimeters. You can stack the spacers and add 2 spacers if you want. That would give you 56 millimeters of clearance if you need it, if you need to measure guitars or something like that, which people have. So just keep that in mind. The spacers work with any IO version, whether it's a Gen 1, a Gen 2, or the new IO3. With our devices, we ship a piece of software called i1 Profiler. We launched version 3 of i1 Profiler last fall. It was the first version where we had transmission profiling. It would allow you to hand scan for transmission applications. A few weeks ago, we just launched our version 3.3 of i1 Profiler. This includes the ability to do automated transmission profiling with the i1 Pro 3 Plus and the IO table. So you can automate it, which is super duper. So let me get a little bit into transmissive profiling. Most of the people that I've worked with who are doing transmission profiling today aren't doing it actually backlit. They'll profile their printed samples in reflective mode and get an okay profile. And that's because most of the workflows that are out there don't support transmissive profiling. So they'll measure it reflective, build a profile reflective, and they'll get usually a better result than no profile at all. But if you profile in transmissive mode with backlighting, you'll get a much better profile, better color accuracy, better saturation, etc., than doing it as a reflective sample. So in this case, this sample was profiled in reflective mode, and this is what it looks like reflective. If you turn the light box on with that reflective profiled piece, you get an okay result, but it looks washed out. The contrast is off, and the saturation's obviously off. If you profile in transmissive mode and you look at it in reflective, you're going to see a dark sample like this one. So this one was profiled with a backlight, but it's being viewed in reflective mode, so no backlight, and it looks dark and muddy. But when you turn the backlight on, it looks great. So it's really about profiling for the application. If you're going to use a sample predominantly in transmissive mode, you're going to get a better profile if you profile transmissively. If you're doing a reflective mode, you're going to get a better profile for reflective applications. Makes sense, but most people are kind of trained to do it the way they have the tools for. So coming in August, it's here. I'll talk about the transmissive process we have. So for hand scanning, you don't have an IO. We have you print the chart. We have you print a Lightbox template. The chart that we have you print is a fixed 100 patch chart. So you don't get to choose the number of spots on it in the hand scanning mode. We have you measure your Lightbox, and that gives us the spectra of the Lightbox. We also have you measure for non-uniformity. So you'd scan across the Lightbox with no chart on it. Then you measure the first chart, set your profile settings. I1 Profiler creates a second chart iterated based on the first 100 measurements, another 100 patch chart. You scan that chart, pick your final viewing Lightbox, which we'll talk about in a second, and then save off the profile. One of the coolest things about I1 Profiler and doing transmissive is you don't have to have the final Lightbox that you're going to display on. So you have a Lightbox you're measuring on, but let's say your display Lightbox is a sign on the Vegas Strip or a bus stop backlit piece. You can measure those or measure something similar and store those as different viewing Lightboxes and apply those in the ICC profile whenever you want. So you use your own Lightbox in your shop, but you have, if you know, a selection of Lightboxes that you're going to display on, and you just select those in the profile generation, and away you go, which is pretty cool. So you can build up a library of different display Lightboxes and use those when you build your profiles. Very powerful. This is what it looks like. So for you set up your Lightbox, there's a template that we print out in I1 Profiler. Where's my mouse? That we have you add to the Lightbox, and that allows us to measure the Lightbox without the chart or with the chart to measure non-uniformity. So we can actually divide out any non-uniformity or any unevenness in the Lightbox. If you're using a Lightbox that's very uneven, this corrects for that. This particular Lightbox is a $30 LED Lightbox I bought off of Amazon, and it's relatively even compared to my very expensive Lightboxes. But it's so convenient and cheap that it's the one I would or similar one most people to use for this application. When we do hand scanning, we actually do scanning measurements of the patches, which is kind of cool. As the device is scanning across and measuring a patch, when it bumps into the edge of the patch, it takes a measurement and another measurement, again at 400 measurements per second, and then averages all those together. We call that our virtual aperture technology. And this gives you a very homogeneous and accurate measurement of the patch. So if there's dust or some unevenness from the ink, it'll generally average that out. And then it basically throws measurements overboard where these black circles are until it comes to the next patch with our automatic patch detection, and then measures and measures and measures and averages again and again and again. But part of the big value of scanning, particularly on reflective materials, is we get this virtual aperture, or this averaging of measurements. All of the measurements, though, in reflective mode and in scanning mode are set for the same exposure time, because in order to get measurements like multiple measurements average like this, we have to use a fixed integration time, or a fixed exposure time, which limits a little bit the quality of emissive or transmissive measurements. So when we do spot measurements, we can actually change the integration time, or the exposure time for each spot. And this allows us to reach saturation on the patches, which is an advantage over scanning. It'll give you generally a much more accurate measurement in emissive mode than you would get in the scan mode with a fixed integration time. Oh, fixed a spelling error there. Very good. So again, in hand scanning, we're scanning. When we're measuring with the IO, because of that advantage in spot measurement of getting full saturation by using optimized exposure times, we use spot measurement when we do automated measurements with the IO. So in hand scanning, we do it with scanning. The IO, we're using spot measurements. So that's a little bit different in how they measure. You're not going to notice a difference as a user much at all in terms of the workflow because of that. But you will see generally better profiles from the automated transmissive measurement with the IO than with the hand scanning measurements because of that. So a little comparison of the workflows here. Another advantage of the IO workflow is because it's automated, we allow you to pick the number of patches for your charts. So instead of the 100 patches that we use in the hand scanning workflow, you can do anywhere from 240 patches up to 4,000 patches if you wanted to, just more pages. In both cases, we're measuring the backlight. We're measuring it for spectral, for spectrum. We're measuring it for non-uniformity. We're allowing you to measure and save any of your display light boxes as well. But while the hand scanning workflow is iterative, it does one test chart and then optimizes for a second test chart. In the IO workflow, it's basically the same workflow we use for print, in that you can pick your number of patches and number of test charts accordingly, and it's a one pass operation. When you get into the software, the first time it'll come up with 3 movies you can play on picking out a light box, which is very helpful. I'll go through the details of light boxes that work for this, or that we recommend, in a little bit. But if you download the version 3.3 software and go through this, it'll give you a really good instructive help on light boxes as well as the workflow. So you pick your patch set. You can profile in RGB or CMYK for transmissive, which is wonderful. A lot of people who are doing transmissive work are doing it in RGB. So we wanted to make sure that they were both enabled. So you pick your number of patches here. Right now, this one's set to 489. We have you measure the back of your, we have you measure the substrate of your that you're printing on the front. We also have you measure the back of the substrate. This gives us an idea of how light might diffuse through the substrate, which we use in part of our profile building calculations. We have you put your light box on the IO and add a template to it so that the IO can find its way across and measure for uniformity, again, for that evenness of light across the light box. Then we have you add your target to the template and scan, scan, scan. Away you go. And again, it's not actually scanning with an IO. It looks like it is, but it's doing spot measurements to get to fully saturated measurements on each spot, which are more accurate. We measure the light box again. There's an option in here to measure and adjust for ambient light as well. And then the standard default profile settings you're used to seeing in I1 Profiler. And then you create your profile. So from a Lightbox standpoint, we want to use low profile LED light boxes, so something without a raised frame, because the I/O needs to be able to move the device over it. These weren't tremendously common back in the days of fluorescent tubes, because everyone had a raised frame on their light boxes. But today there's so many LED light boxes out there, and they're so incredibly cheap that they're very common. Again, the A4 light box that I use, I think I paid $26 for on Amazon. If you have a thicker light box, you may want to go with an I/O spacer, a Z-axis spacer. But again, the LED light boxes, the thin ones that are out there, are somewhere in the range of 4 to 6 millimeters thick. So no need for a spacer with those. You can get larger light boxes if you want them. A4 is perfect for an I/O, but if you're also doing hand scanning, you may want to get an A3 or an A2 light box, which is much bigger than the measuring space on the I/O. But you'll have it if you need it for anything else. A lot of the light boxes that are consumer light boxes that are out there right now, some of them have color temperatures way up in the 10,000 range. Try to avoid these. The less correction that the algorithms have to do on our end, the better profile you're going to get. So if you're looking in the comments to order a light box, see if you can find one that's closer to 5K or 6K or degrees Kelvin, 6,000 degrees Kelvin, 5,000 degrees Kelvin, something like that, that's in range with something more normal. And that's it. Any questions?
Perfect. Thank you, Jay. Yes, if you do have any questions that you haven't asked, feel free to submit a question now. I'll give everyone some time to submit a question. While we wait for questions to come in, I will pop up another polling question. In the event that you are interested in talking to a sales rep or someone else one-on-one, feel free to take that. I see one question that has already come in. So someone's asking, what is the use and benefit of a M3 reading when creating a backlit profile?
There really isn't a benefit that I've found in using M3 for transmissive. We don't even allow it in our current software. We block it. So good question. I should have gone over that and mentioned we don't use M3 for transmissive. M3 or polarization is incredibly valuable with different surface materials. If you're using a fabric or a canvas or something with a weave in it, you'll often get specular reflections in the highlights and even in the shadows, and a polarized measurement will suppress those. For photographers, we're finding a ton of photographers who use super glossy papers, again, reflective, like F-surface photographic papers. And M3 will block reflections in the shadows and the deep blacks that would show up under normal measurement and give them a much better gamut and much better profiles for those types of materials. Historically, in traditional analog printing, M3 would be used for correcting for ink dry down. So if someone had a fresh print off a press and they wanted to cut down on some of the reflections that come from wet or not fully dried inks, they'd use M3. But in the digital world, it's fantastic with materials that have uneven surface or textured patterns like a polyester or canvas as well.
Great. I'm not seeing any more questions come in right now, so we will end here for today. Again, we will send out this recording tomorrow, and if you do have any questions, feel free to send them in, and I can direct them to Jay. So thanks, everyone, for your time, and have a great rest of your day.
Bye.